If you look back at all the definite integrals that we've done so far in this class, and the ones that we did back in first semester calculus, you'll see that they have a few things in common. First, the limits of integration were always a finite range. For example, we might have tried to find the integral of f of x from 1 to 4, but not the integral from 1 to infinity. And the second thing they all have in common is that the integrand was also finite in the range that we were integrating over. So with g of x, for example, we might have found the integral from 0.6 to 1. The function is finite on that range, but not the integral from 0 to 1, since the function is goes off to infinity over there at 0. Now, integrals like these two that don't meet these requirements are called improper integrals of the first type if the domain of integration is infinite, and improper integrals of the second type if the function becomes infinite on the range that we're integrating over. So in the next lectures, we're going to look at these two types in detail and see how sometimes these integrals will actually have finite results. So we're going to look at both of these types in much more detail in the next two lectures, but I didn't want to leave this one without showing you at least one specific example so you can get the general idea of how we're going to handle these. All right, so here, this is actually a problem from the left side of the last slide. Right, I want to evaluate this integral, and finding the antiderivative of this isn't difficult. We just think of the function here as negative x to the negative second, and the antiderivative we're going to use will be negative 1 over x. So now what do we do? Right, we can evaluate this from 1. That part's not a problem. Right, but we really can't put infinity up there. Infinity isn't a real number. You can't go evaluating functions at that value and so forth. So what we're going to do is what we've always done throughout this class and the previous one. When we want to talk about what's going on with something at infinity, we're going to rewrite this as a limit. So I'm going to put b up here, and then I'm going to put the limit as b approaches infinity over here. And this is something we can evaluate. This is the limit b approaches infinity, negative 1 over b minus negative 1 over 1. And I'll do the limit in a minute, right? Let's simplify this first. This is the limit b approaches infinity, negative 1 over b plus 1. The limit, you split the limits up, right? The limit as b approaches infinity of negative 1 over b is 0. And the limit as b approaches infinity of 1 is just 1. 0 plus 1 is 1, and there's our answer, right? That's what this indefinite integral is equal to. All right, so now you've got the general idea of what we're going to do here. All right, so in the next two lectures, we're going to look at each of these two types and just be more precise about this method and look at some examples of how to use it.